Professor Jeff Wilkerson at Luther College here with an introduction to Exercise 3 from Astronomers as Observers and Experimenters, a laboratory manual for introductory astronomy classes provided by Kendall Hunt Publishing Company. And what we're going to talk about here is we're going to talk about maybe not the procedure and the exercise quite so much as we are in three of the guides that are referenced therein. Constellation charts, which you'll find in the back of your lab book, and planispheres, which you can make one out of the diagram on the back cover of your lab book, or you might have access to others, and the astronomical almanac that you see right here. This one's for the year 2020 that I just picked up off my shelf. So we're going to look at these three. We're going to spend the vast majority of our time looking at the constellation charts. The constellation charts are probably the most helpful for you, the most useful. We want to make sure you have a little bit of facility with them. They are referenced in a few of the exercises throughout the book and the projects at the back. In particular, Project 2 requires you to use the constellation charts significantly. These constellation charts are in the back of your book, but they're also available online. If you just do a search online for constellation charts, you'll be able to print these off. And you want to be able to do that because you might want to be able to write a lot of different things on a lot of these constellation charts. So you want to have several of them available to you to mark up. What they are is essentially a graph of declination up this way. Remember, declination is the projection of latitude lines onto the sky, and right ascension across here. And right ascension is the projection of longitude lines on the sky. So you've got right ascension as the horizontal axis of your graph, and declination as the vertical axis of your graph. Because the sky, when we look at the sky, that's the celestial sphere we're talking about. And when we look at the inside of the celestial sphere, it's curved, and so the projection onto a flat page would cause curvature here that would be difficult, would be challenging. We have this broken into the equatorial region, and then you can get these for the polar regions. Your book just has the North Polar region included. You could get this for the South Polar region as well. So you have a constellation chart for the the North Polar region right there. The equatorial regions are broken into two 12-hour chunks. So this one is 12 hours to 0 hours of right ascension across here, and then you'll have 24 hours to, 0 and 24 is where it wraps back over to 12 hours of right ascension across here. So right ascension is measured in hours and minutes. It's not a time, it's a position, but it wraps on itself 24 hours, so you can think about the celestial sphere as being the sphere of the stars that we see above us as the Earth rotates. The stars move from east to west across the sky. We call the zenith point, the point that's directly above us, and we call the meridian the line that connects north to south through the zenith point. So you're going to use these ideas in exercise 3, and you're going to ask what's in the sky when, and where can you find things in the sky looking at your constellation charts. And so we use this hours of right ascension as your measure. Every 1 hour of time, a different hour of right ascension moves on to the meridian. So if 7 hours of right ascension is on the meridian, the point that's directly on the line that's directly overhead, connecting north to south, if 7 hours of right ascension is on the meridian when you're looking now, 8 hours of right ascension is going to be on the meridian an hour from now, then 9 hours. A way I like to think about it is I like to picture the meridian line as being attached to me. Wherever I go, the meridian line is fixed above me, this line, and the sky is sliding behind that meridian line. And the sky, the fixed stars, have fixed right ascension and declinations more or less. Precession and proper motion changes that a little bit, but those are topics for another time and another place. But to say the fixed stars have a given star, Regulus, has a given right ascension and right declination. Orion, a constellation, has a range of right ascensions and declinations that encompass that constellation. And those right ascensions and declinations of those stars, those are attached to those stars, sliding behind the meridian line, rising in the east, sliding behind the meridian line, and setting in the west. over here. So that's what we're working on right here. So we'll ask the question, what's on the meridian at midnight tonight? There's a couple of ways you can do that, okay? One way you can do that is to say, on the meridian at midnight tonight, if I look down here, I can find dates below the hours of right ascension on this horizontal axis. There are dates printed. So for example, you get a constellation chart out in front of you, you'll see that, let's say, 5 hours of right ascension has the date February 5th printed below it. If you read the fine print over on the left, it says each hour circle is labeled with the date on which it coincides with the meridian above the celestial pole at 8 p.m. local time. So that means 5 hours of right ascension is going to be on the meridian on February 5th at 8 p.m. Great. So if we know 5 hours is on the meridian at 8 p.m. on February 5th, that means that 6 hours is going to be there at 9 p.m., 7 hours is going to be there at 10 p.m., 8 hours is going to be there at 11 p.m., and 9 hours is going to be there at midnight. Okay, so if I wanted to know, if it's February 5th, and I wanted to know what was going to be on the meridian at midnight tonight, I would be 9 hours of right ascension, according to the calculation we just did. And so that's one way into this. Now, because of you'll see more about this in the Sidereal Day Lab when you're looking at that exercise, but because of the rotation, so there's the sun, and there's the Earth, and we have moved a little bit in our orbit when we have completed one rotation. So we're rotating around that way. We've moved in our orbit. We have to over-rotate a little bit to get the sun back directly overhead to its highest point in the sky, not directly overhead, unless you're someplace in the tropics. But get it to its highest point in the sky, we have to over-rotate just a little bit. And so the stars are so far away, they don't need that over-rotation. They get back in one rotation of the Earth. They get back to the same point in the sky. So the sidereal day measured by the stars is different from the solar day measured by the sun. And so the stars rise 4 minutes earlier. The result is the stars rise 4 minutes earlier each night. And so with the stars rising 4 minutes earlier each night, that means that over the course of a month, approximately speaking, the stars rise 2 hours earlier. So back to our chart, we can say, on February 5th, 5 hours of right ascension was on the meridian at 8 p.m. A month later, the stars will have risen 2 hours earlier, so 5 hours of right ascension is going to be on the meridian at 6 p.m. If we went a month earlier in the year, that would be a month later would be March 5th. If we went a month earlier in the year, it would be January 5th, and January 5th, 5 hours of right ascension would be on the meridian at 10 p.m. Because it's getting earlier and earlier and earlier as you march through the year. And you can work through here and double check all of what I'm saying. See if you can just say that. Well, let's just do it. Let's just find March 5th. And at March 5th, it says just about 7 hours of right ascension is on the meridian at 8 p.m. So if 7 hours of right ascension is on the meridian at 8 p.m., that means the stuff that's west of the meridian was on the meridian earlier at night. So 1 hour west is 6 hours, would have been on there at 9 p.m. and would have been on there at 7 p.m. And another hour, 5 hours earlier, would have been there at 6 p.m. That's what we said. And a month later, March 5th, the stars 5 hours would have been on the meridian at 6 p.m. So try working through that. Try practicing going through these sorts of things. And then also look at this curved path that you see right here. That's the apparent path of the sun through the sky. We call it the ecliptic. So now, as we're orbiting the sun like this, we see the sun projected against the distant stars back there at a different location as we orbit around. And that path is that location that we see against these fixed stars. So the right ascension and declination of solar system objects is changing. The right ascension and declination of the sun is changing throughout the year as we orbit. And so we can look over here and we can say the date, that there's dates printed underneath this ecliptic path. Perhaps you can see them there. The date is, let's go find February 5th. We've been working with February 5th. It's going to be on the other chart. So we flip over to the other chart, and I see February 5th is approximately it says February 10th is about February 10th is about 21 and 3/4 hours of right ascension, and February 1st is about 21 hours of right ascension. These are rough approximations. So somewhere between 21 and 22 hours of right ascension, it says the sun is at that location. That's when the sun is at that location. About February 5th, going to be about 21 and a half hours of right ascension that we're going to have right there. So we can look at that and we can say if that's the right ascension of the sun on that date, halfway around the sky is 12 hours of right ascension. That's what's going to be on the meridian at midnight. So on February 5th, we're going to claim on the meridian at midnight is somewhere in the neighborhood of 21 and a half minus 12 hours of right ascension. 24 hours of right ascension covers the entire sky. 12 hours of right ascension is halfway around the sky like this. So there's the sun, halfway, as far away from the sky as you can get in the sun. That's what's on the meridian. That's what's directly overhead at midnight. And so that's 12 hours of right ascension away. 12 hours of right ascension away from 22, let's say, is 10 hours of right ascension. It's 9 hours of right ascension from 21. And so 9 hours of right ascension is what's on the meridian at midnight on February 5th. And we said on February 5th, 5 hours of right ascension was on the meridian at 8 p.m. You move 4 hours, and that's 9 hours of right ascension that's on the meridian at midnight. So if 5 hours is on the meridian at 8 p.m., 6 hours is on the meridian at 9 p.m., 7 at 10, 8 at 11, and 9 at midnight. That's the same 9 hours we got from walking halfway around the sky from the sun. Hopefully you can see that geometry. You can say, well, if I'm looking at the sun right here, don't look directly at the sun. But if you're looking at the sun right here, midnight, what's on the meridian at midnight directly overhead is going to be over here. And that's night over here. And we can say that's halfway around the sky. The sky's measured in 24 hours of right ascension. That's 12 hours of right ascension. So we take the sun's position, subtract 12 hours, and that's going to give us the right ascension that's on the meridian at midnight. So exercise 3, star charts and catalogs, is asking you to practice this work. Just really go after it and get to know these constellation charts. You want to treat these, as I said, this is like a graph of right ascension and declination. You want to treat it like graph paper and plot positions on here. You'll find the positions of objects and plot them right on here. And one of the things you'll do that for is if you have access to the Astronomical Almanac or some data like this from the Astronomical Almanac, you can just look it up online, data for solar system objects. It's going to give you, you're going to find, for example, here is Neptune 2020 geocentric coordinates for 0 hours of terrestrial time. And so that's going to be the coordinates, Earth-based geocentric coordinates of Neptune on this date. It's going to have a right ascension and a declination for the various dates. You read the date, July 5th, right ascension, declination. Read the date over here, October 4th, right ascension, declination. You can take that right ascension and declination, paying attention to minus signs for your declination, and plot them directly as a graph. Find the right ascension, find the declination, and plot that right on here. And one of the things you want to do is to look to see the pattern of all the solar system objects. Where do they fall relative to the celestial equator, that 0 hour, that 0 declination line across there, or the ecliptic, that curved path across there, or anything else? What pattern do you see, and what does that tell you about the geometry of the solar system? Can you take a simple observation like this and turn this into a powerful model of how the solar system works? So this is one of the things that the Astronomical Almanac is really good for, is giving us the positions, and we can use that to tell what's going to be in the sky tonight. We can say, oh, I know that at midnight tonight, I know where the sun is. At midnight tonight, it's 12 hours away from there, or I can read across what's going to be on the meridian at 8 p.m. tonight, and so I can find out what's on the meridian at 9 p.m. by using the dates on the bottom of the constellation charts, 10 p.m., 11 p.m., 12 p.m., whatever. I know what's up at night. I can ask which of these solar system objects is going to be visible in my sky tonight. Go out and look for it. So that's how we're going to use the Astronomical Almanac. The planispheres are great. They're a quick way. They don't give you the coordinates. So it's not like a graph of the coordinates so much. The coordinates are on there. And so they really do give you the coordinates. You can see the declination is on here. I don't see the right ascension so much on this one. There might be one that has it, but you can see the declination of the objects printed here. So what you do to use the planisphere as a quick way to check, this is most like the apps that you might have on your phone to say, I'm going to look at and hold it up and see what's in the sky above me right now and get a good quick overview of what's in the sky. Less precision than what you're getting from the constellation charts or the astronomical almanac, but a good quick view of what I might be able to go outside and find, and it's good to get comfortable with one of these or with the app on your phone that does that. And so what I'm going to do is I'm going to take a date and align it like October 15th. So I see October 15th right there, and I'm going to align it with the time. I'm going to say October 15th at 8 p.m. I went too far. So there, I've aligned October 15th with 8 p.m., and I'm going to be able to say the meridian is going to be the line that connects north and south directly overhead. It's going to go right through this hole right here. You could tie a string through there and find your north-south line overhead like this. And so to say, okay, here's my north-south line, and I'm going to find what constellations and objects are directly overhead at 8 p.m. tonight. So I'm going to be able to do that, and then I'm going to go compare it to the constellation chart. I'm going to look up October 15th below the date of an hour of right ascension right here, and when I find October 15th, I'm going to compare that hour of right ascension and see what constellations are on here and compare it to what I got when I looked at the planisphere here. So the planisphere gives you a quick glimpse of everything that's in the sky. The constellation chart is going to give you a little more precision if you want to go out and measure things. You're going to practice both of these in this exercise, or you have the opportunity to practice both of these in this exercise. I do encourage you to get accustomed to the constellation chart in particular, because it's going to be very helpful for other activities, other exercises in the laboratory manual, and other projects that you might be working on. So that's really what we got for you here today. Your introduction to exercise 3, constellation charts, planispheres, and astronomical almanacs. Hope everybody enjoys doing this exercise and getting to learn the night sky a little bit from it.